In this video for section 2.1, we're going to talk about frequency distributions, also called frequency tables, and they show the number of observations in each category or class for a data set. So for example, if we have this data set, it shows the number of product categories per customer at the Dallas Walmart. So for example, this 4 means that this particular customer purchased products from 4 different categories, things like grocery, health and beauty, things like that. So it's a little bit hard when you're looking at this data set to understand what the data is telling you. But if I put it in a frequency distribution, I can get a better idea. So this is what the frequency distribution would look like. So for example, the number of customers who purchased from 3 different product categories was 42. 42 customers purchased products in 3 different categories. And when I have it like this, it's easier to see which number of product categories was most common. The largest frequency here is 92, and so that means 4 was the most common number of product categories, followed closely by 5. So sometimes we want to use percentages instead of just numbers, and this is especially true if we want to compare from 2 different data sets and the total number of observations is different. So in this example, we were surveying the number of years of college that different people had in 2 cities, Philadelphia and Knoxville. 160 people were asked in Philadelphia, 330 people were asked in Knoxville, so over twice as many. And that makes it hard to compare the actual numbers. So instead, we want to compare the percents. So we divide each frequency by the total number. So in Philadelphia, we're dividing frequency by 160. For Knoxville, we're dividing the frequency by 330. And that gives us a percentage, and we can more easily compare it. So for example, if we look at 3 years of college, 22 people in Philadelphia said that they had 3 years of college, and 19 people from Knoxville said that they had 3 years of college. Those 2 numbers are pretty close. However, looking at the percentages, we see that it's over twice as many in Philadelphia as it was in Knoxville. And so that tells us that those actually are quite different. We can create a frequency distribution for either qualitative or quantitative data. So the examples that we've seen so far have been quantitative data. We have number of years of college, and we have number of product categories. Table 2.5 shows us a frequency distribution for qualitative data. This is TV source, and then we're looking at how many people responded that they used that source. So 80 people responded they used Dish, 90 people use DirecTV, 20 people use cable, and 10 people use another source. So we're going to look at example 2.1. It says a survey of 16 real estate agencies was conducted to collect data on the number of real estate transactions closed in December 2008. The following data were observed. So for example, this 3 represents one real estate agency who reported that they closed 3 transactions in that month. We want to create a frequency distribution and a relative frequency distribution for the number of real estate transactions. So I'm going to have number of transactions for my first column in the table. And looking at my data set, the number of transactions could have ranged anywhere from 0 to 4. So, and it obviously has to be a whole number. So we have 0, 1, 2, 3, and 4 is the highest number in my data set. So now for frequency, I'm going to count how many times each one occurred. So 0 occurred 1, 2, 3, 4, 5 times. 1 occurred 4 times. 2 also occurred 5 times. 3 occurred once, and 4 occurred once. So those are my frequencies. Now for the relative frequency, what I need is the total number of observations. So this is sometimes given to you in the problem. My problem says that I surveyed 16 real estate agencies altogether, or you can get it by adding up the total numbers in the frequency column. So those numbers add up to 16. So for the relative frequency, I'm dividing each frequency by 16. So 5 divided by 16 is 0.3125. Just use a calculator for this. We have 4 divided by 16, which is 0.25. Another 5 divided by 16, 0.3125. 1 divided by 16, which is 0.0625 or 6.25%. And another 1 divided by 16, so another 0.0625. And if I add up all of my relative frequencies, that should add to 100%, or 1.00 if I add them in decimal form. Sometimes our data values will be more spread out, and so it makes more sense to use a range, or we call it a class, to group the data, instead of each individual number having its own row. So in this example, table 2.7 shows the frequency distribution of streamed movies. So number of movies streamed in 1 month in Netflix. So for example, 12 people streamed 15 movies in that month. Now, there are a lot of numbers in this table, and so a way to make it a little bit easier to read is to use ranges. So 0 to 3 movies, 4 to 7 movies. You want each of these ranges to be the same width so that your comparisons are fair. And then you just add up the numbers. So for 0 to 3, I would add 8 plus 8 plus 22 plus 22, and that gives me the value of 60. So the ranges make it a little bit easier to read the data. And lastly, we have what's called a cumulative frequency distribution, where the number of values in all smaller classes are added to the number of values in each class. So if we take our frequency distribution above, these are the numbers, and then for cumulative frequency, you add the value of the row above to get the value in that row. So for example, 60 was 0 to 3 movies, 50 was 4 to 7 movies. I add the 50 to the 60 above to get 110. Then we have 47, 8 to 11 movies. I add that to the 110 to get 157. Then I add 40 to get 197. So you're always just adding your value to the value above. And when you finish, your last row should have the total number. It should be the same as the total number because everyone should be counted in that cumulative frequency. And if you do relative frequency, dividing by the total number, your last row will have a value of exactly 1. So that is a cumulative frequency distribution.